Hey guys, I'm Mrs. Cofield and I would love to welcome you to lesson number 10 of the Operations on the Real Numbers course. Today we have quite a bit to cover, so we're going to go ahead and jump right in. We're going to be talking about multiplication. We'll cover basic properties, multiplying integers, exponents, and we'll discuss the main principle of multiplication. I hope you guys are ready because I'm ready. Let's go. So, we talked before about the definition of algebra. Algebra, we said, was the study of the operations on the real numbers, right? And you know what I mean by real numbers. The real numbers are integers such as positive and negative numbers and all the numbers that live in between those guys. So we're talking about decimals, fractions, and mixed numbers as well. All of these types of numbers are the real numbers. But then we also talked about that myth. They told you guys back in the day that there were four main operations. Those four operations being addition, subtraction, multiplication, and division. But we got rid of that myth, right? And we told you guys the truth. In reality, there are only two main operations. Those two main operations are addition and multiplication. We did talk a little bit about subtraction too, but we learned that subtraction is just addition of the opposite, right? So, we got that big guy out of the way and its sidekick, but now we're going to get into the next big guy, and that is multiplication. I hope you guys are just as pumped about this as I am because it's about to go down. Here we go. Multiplication. There are several facts that you need to know, okay? And we're going to talk about some of those basic ideas today. So, the first basic idea I want you guys to write down in your notes is that the number 1 is the multiplicative identity of the real numbers. Again, the number 1 is the multiplicative identity of the real numbers. For example, what this means is that A times 1 equals A, and A can represent any real number. So if we look at a real life example, it's like this. 4 times 1 is equal to 4, and then 1 times 4 is also equal to 4. So when you multiply anything times 1, you get that same number, such as 4 times 1, and it gives you 4, okay? So let's talk about another basic idea. Number 2. Every real number except 0 has a multiplicative inverse or reciprocal. Again, every real number except 0 has a multiplicative inverse or reciprocal. Now this is what I mean. For example, if you want to take the number 5, you all know that 5, if you had to write it as a fraction, 5 as a fraction is 5 over 1, right? But to make it a reciprocal, all you have to do is just flip it. So if you have 5 over 1 and you flipped it, you get 1/5. You get that? Let's try another one. So what is the reciprocal or the flip of 2/3? Well, the reciprocal is 3/2. Good. Now, I want you guys to notice something special right here. Check this out. If I were to take that 2/3 and I multiply it by its reciprocal, I get the number 1. Did you see that? Because technically that would be like 6 over 6, and 6 over 6 is just a form of 1. All right, let's move forward. Our next basic idea states that multiplication is commutative. Now, I know we've seen that before when we talked about addition, but it also applies to multiplication. And you remember what commutativity means, right? That means that for any real numbers, A and B, A times B is just equal to B times A. You see how we kind of just like reverse the order there? That's commutativity. So, for example, 2 times 3 is just equal to 3 times 2. All right, you guys have learned all those basic ideas. Now let's go. Let's apply some of this stuff. Here's an example. Now let's talk about integers. Now we're going to multiply 4 times 5. Now you already know that that's 5, 10, 15, 20. All we have to do is multiply as regular and we get 20. What about in a case like this? 4 times -5. Now, what would that look like? Well, if you think about it, multiplication is really just like repeated addition. So you're really saying that you want to write -5 plus -5 plus -5 plus -5. If you add up all those -5s, then how much do you get? You get -20. Well, guess what? Even if we were to flip those numbers around and say -4 times 5, then essentially it's the same thing because you're adding -4 plus -4 plus -4 plus -4 plus -4, and again, that gives us -20. But what about a case like this? What if we took that -4 and we multiplied it by -5? There's something I want you to know. Whenever you're multiplying a negative times a negative, that answer turns out to be positive. So -4 times -5 is a positive 20. So as we think about that, this is something that I want you to take into mind. Whenever you're multiplying, a positive times a positive is always a positive. And then a positive times a negative is always a negative. And then, like I just told you, a negative times a negative, that's always positive. But guess what, guys? This doesn't just apply to integers. It applies to all numbers. And when I say all numbers, I'm talking about it applies to fractions, mixed numbers, decimals, all of that. A positive times a positive is still a positive. Positive times a negative is a negative. And a negative times a negative is a positive. That's for all real numbers. So let's move forward and see what's next. We're going to talk about something else that's very special, a very special way that we can multiply. And it's called exponents. And we think this is pretty cool, okay? So here's an example and a definition of what an exponent is. An exponent is a simple notation for writing a number multiplied by itself a certain number of times. So for example, 5 to the second power. That number 2 right there, that's the actual exponent. But whenever we see 2 as an exponent, we call that 5 squared. So 5 squared is telling us how many times that we're supposed to multiply that number 5 times itself. So 5 to the second power equals 5 times 5, because we're multiplying 5 times itself 2 times, right? But what's 5 times 5? That's just 25. Easy, right? And they tried to tell us that multiplication was harder. Like, oh my God, this is so simple. What about this one? 2 to the third power, because that power, that exponent is a 3. There's another way that we can call this, and we usually take the third power, we call that cubed. So the way we can say that is 2 cubed. So essentially what that means is 2 times 2 times 2. Now we know that 2 times 2 is 4. 4 times 2, the full answer is 8. So 2 cubed, or 2 to the third power, is equal to 8. Let's try another one. Now, we're going to be working with powers that have to do with the number 10 now, right? So we have 10 to the 6th power, right? So what that means is that we have 10 times 10 times 10 times 10 times 10 times 10. That's 6 times, right? Man! So let's go through and let's multiply that out. So we know that 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. 100,000 times 10 is 1,000,000. Woo! Oh my God, look at that number. Do you all see a relationship between the number of zeros we have and this exponent here? Well, check that out. There are 6 zeros, and our power, or our exponent, was also 6. Wow. What this tells us, guys, is that whenever we're working with the number 10, like 10 as a base, and we raise it to any power, is that that's the amount of zeros that we're going to have. We kind of could have saved ourselves, this extra time writing out all those 10s. Let me show you another example. Let's get crazy with it. We like this base of 10. What if I took 10 and I said, how about 10 to the 12th power? Let's see what that looks like. 10 to the 12th power. Woo! I told you, we could have taken a shortcut, but here it is in its long version. We have 10 times 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 10. Woo! Well, if I wanted to just take the shortcut, like I said, and just write it out, I know that my final answer should have 12 zeros. And you can go ahead and check it and make sure it's 3, 6, 9, 12 zeros in there, right? And that number is 1 trillion. So 10 to the 12th power is 1 trillion. But I'm telling you, I'm loving this shortcut though. To just know that I can just look at that exponent and just know how many zeros there are, that's pretty cool. Make sure that you keep that for your notes, okay? All right. Ooh, check this one out. Now we have a -2 to the 5th power. We haven't done negatives yet. But when we're doing a problem like this, it's important to remember what we just said regarding a negative times a negative being a positive and a negative times a positive being a negative, right? And also a positive times a positive being a positive. Because if you're going to be multiplying that -2 a bunch of times, then you got to know how to switch those signs. So here's what it would look like. -2 to the 5th power is basically -2 times -2 times -2 times -2 times -2. Now let's go through and evaluate. Here we have a negative times a negative, and that is a positive. And then we have a positive times a negative, and that is a negative. And now we have a negative times a negative, and that is a positive. And now we have a positive times a negative, and that is a negative. So we know our answer is going to be negative, but now it's time to do the easy part. What's 2 times 2 times 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, that's 32. So we know our answer is going to be -32. That was pretty cool. So make sure that whenever you're working with those negatives as a base, that you really pay attention to the signs, because you want to make sure that you get the right sign in the end, okay? Here we go. Let's move forward. So, as we work with all these different problems, I want you guys to now be introduced to the main principle of multiplication. And what it says, guys, is that you can multiply anything times anything. Now, I must say, that statement is a trip, considering this. All our lives we're brought up thinking, we're going to start with addition because it's kind of simple. Then we move on to subtraction. But then it's like when we're growing up, they show us that multiplication is supposed to be harder, right? It's more difficult. But that's not true when you move on to more advanced mathematics. The higher you go with this, multiplication, that's the easy stuff. Because you can multiply anything times anything. You don't have to get a common denominator. You don't have to do all that stuff we did with addition and subtraction. I'm telling you, the game has changed. This is easy. So let's go ahead and give it a try. Let's multiply fractions. Now, like I said, can you multiply thirds times sevenths? Yes! You can! You can multiply thirds times sevenths because you can multiply anything times anything. So all we have to do to multiply a fraction, so let's just multiply straight across. We know that 2 times 5 is 10 and 3 times 7 is 21. So we end up with 10 21sts. Boom! That was so nice. What about this case? Can we multiply fourths times fifths? Well, absolutely yes, you can. And why? Because you can multiply anything times anything, all right? So let's just multiply straight across and get it on over with, because this is like easy as pie. Because 1 times 11 is just 11, and 4 times 5 is 20, and we have 11 20ths. Woo! This feels like a celebration. I hope you guys found this multiplication easy. Let's review some of the stuff we just talked about today, because I am well pleased, and this was so exciting. So here we go. Let's talk about those basics. The number 1 is the multiplicative identity of the real numbers. Point number 2, every real number except 0 has a multiplicative inverse or reciprocal. Flip it. And then number 3, multiplication is commutative. And an exponent is a simple notation for writing a number multiplied by itself a certain number of times. Remember that exponent tells us how many times we have to multiply that number by itself. And now, my favorite, the main principle of multiplication. You can multiply anything times anything, and that is worth celebrating. Wow, guys, this has been a phenomenal day. We've learned the basic properties of multiplication. We've multiplied integers, and we've gone over exponents. We've even talked about the main principle of multiplication. That was a lot, guys. But you guys rock. You guys knocked that out of the ballpark. And there's so much more to come, okay? So, have at it. Go ahead and get that work done and show them how easy this multiplication has been. I know you guys have been waiting for this one. All right, take care, and I will see you guys tomorrow. Have a wonderful day.